Hi, I'm Molly. To continue our quantum theory video series, we're going to be taking a look at the mustard FET limiter, the green one. FET limiters, also referred to as compressors, are a common tool when it comes to mixing audio. They were first designed with the aim of achieving a faster attack time than any other solid-state compressor available at the time. The most influential FET limiter is arguably the URI 1176, which was first developed in the late 60s. Anyone who knows about compressors has heard of an 1176, and even if you haven't, you're more than likely to have heard it being used plenty of times on records without even realising. It's inspired many other FET limiter designs over the years, and also plenty of plug-in emulations. You may well have your go-to FET limiter plugin, but on a quantum console, mustard processing gives you access to low latency, native processing visible directly from the channel strip. Let's take a look at exactly what we mean by FET limiter. A FET limiter design is based all around a field effect transistor, or FET, to control the amount of compression. The FET itself operates like a variable resistor controlled by a signal. When the control signal, or sidechain, increases, less of the program signal is allowed to pass through the FET. In the context of an audio limiter, this means that our sidechain can be used to control the amount of gain reduction applied to the audio path. A FET limiter is a form of feedback compressor. This means that the output compressed signal is fed back into the compressor and used as the sidechain. These limiters are also peak detectors. This means that they work well on drums, preserving transient waveforms, as opposed to smoothing the average dynamics of the signal. One accidental feature of the original 1176 was found when setting the ratio. The original design had 4 buttons for the ratio: 4:1, 8:1, 12:1 and 20:1. These were designed to be mutually exclusive, meaning pressing one button would deselect the others, so only one could be selected at a time. It was discovered by British sound engineers that all buttons could be pressed at once, resulting in more harmonic distortion with distinct character. This technique became popular and was incorporated as an all button or British mode on later hardware and software units. Let's have a look at the controls on our FET limiter. It has slightly different controls to what you might be used to on a compressor. Instead of a threshold to pick at what level the compression occurs, this is controlled by balancing the input and the output controls. You can think of it as having a fixed threshold. Turn up the input to compress more, and turn down the output to compensate for the level increase. Attack and release control the speed that the limiter kicks in and then releases. A number of FET limiters, both hardware and software versions, have these controls reversed, so that turning up the attack is actually making it faster. On our mustard FET, we have kept these controls as standard, so turning up the attack means a longer time. The ratio is controlled by a button that scrolls through our different values: 4:1, 8:1, 12:1, 20:1, and the famous all setting. And since it's a mustard limiter, we have our mix control, which allows you to blend between the uncompressed and compressed signal, making parallel compression super easy. A lot of compression can be achieved with a FET without making the signal sound smashed. This can be useful on lead vocals, for example, if you need to keep them at the front and centre of a mix. If driven far enough, the added distortion can be suitable for things like rock vocals that benefit from some added grit. FET limiters are often used when mixing drums, either for individual drum microphones, room mics, overheads, or even the whole drum bus. This is because they preserve the punchiness, but can also add some aggression. It doesn't just stop at drums. FETs are also commonly used on vocals, bass, and guitars to add a little more excitement. If you've got some good quality headphones or in-ears, now's the time to plug them in, as we're going to have a listen to the mustard FET limiter in action. I've got a drum loop here. The individual drum channels already have some slight processing on them just to clean them up a bit, and they're all being fed to a group, which is my drum bus. Let's have a listen with no compression and then turning on the FET limiter. Notice how it's extending the length of the snare, so bringing up the tail of it. Also, have a listen to the difference in level between the hi-hat and the snare. Now let's turn it all the way up and go into all mode. You can really hear how it's starting to add saturation now. Yet it's still quickly able to tame the peaks. I've got a second audio example here, this time a vocal. Notice how the end of the word goodbye is a lot louder than the start of it. Let's have a listen without any compression.
Goodbye, goodbye.
And with compression.
Yeah, goodbye.
You can hear it's quickly taming the transients without completely destroying them.
Yeah, goodbye. Goodbye. Yeah, goodbye.
Now I'll turn it all the way up.
Yeah, goodbye. Goodbye. Yeah, goodbye.
You can hear it is compressing the signal, but it's not completely destroying it again. This can be useful for helping to flatten the overall level of the signal of the vocal to keep it front and centre of the mix. Today, we've had a look at how the mustard FET limiter works, what the characteristics are, and where it might be useful in your own mixing. So next time you're on a Quantum console, why not give it a try before reaching for your plug-in rack? Check out our YouTube channel for more videos on quantum processing options.